Hi children, welcome back to the online session. As you know that we had planned for a thorough revision on the binomial theorem, which is also an important part as far as scoring is concerned in the examination. Now we do have lots of questions, lots of examples I had put across, but before I go to the core examples, I just want to touch all the major points of the binomial theorem, explore to the different types of sums which will be coming on binomial expansion or binomial theorem, and we will see one by one what it is. But before we proceed to the examples, let us go through the revision of binomial theorem. What is exactly binomial theorem? What are the types which are involved in binomial theorem? So all the stuff we will try to work out. So let us see now. Okay guys, let us see. The first point which I want to share with you is the binomial theorem helps us in opening up the bracket of a plus b raised to n. How it happens? Very simple. It's always you use lot of combination here. So my best bet would be use your the best bet is use the calculators to get the combination values, okay, and then we go ahead. Anyway, coming to a point, let us see if a plus b raised to n is there. Binomial theorem helps us in opening up this particular thing. It can be 2, 3, 4, 5, 7, 10, 12, 15, whatever it is. So NC0, first term, okay, first term raised to n, second term raised to 0, plus NC1, first term, remember it is n minus 0 n, first term raised to n minus 1 and second term raised to 1, plus NC2, first term raised to n minus 2 and second term raised to 2. Similarly, first term NC3 and first term it is n minus 3 and second term raised to 3, and so on. This expansion goes depending upon n, right? So NC0, it starts from NC0, NC1, NC2, NC3. First term is raised to n, first term difference of n minus 1, first term difference n minus 2, first term n minus 3, and the second term, of course, you can observe this 0, 0, 1, 1. So this is a way of remembering these expansion values, okay, or formulas. Now it goes on and ends at NCn, first term n minus n will become 0 and second term is n. So this is exactly the expansion of any expression with the form of a plus b raised to n format. Great. Now let me just give an example and try to put the point in front of you all. Let us take an example now. Suppose if you have, okay, the first point which I want to explain is the expansion. Second point is whenever you have a plus b raised to n, the number of terms, the total number of first term, second term, third term, fourth term, fifth term, the number of terms after expansion happens to be number of terms after expansion is n plus 1 term, terms. Okay. Now let me just give an example for it. Now let us see if I say, okay, I am just giving an example, say x plus 1 upon x whole raised to say 5. So I am showing the expansion of this. So first always remember it is 5c0, first term raised to 5 and second term raised to this term, plus 5c1, first term raised to 5 minus 1, 4, okay, and second term is raised to 1, plus 5c2, x raised to 3 1 upon x raised to 2 as it is, plus 5c3 x raised to 2 1 upon x raised to nothing but 3. Now remember, it goes 5c0, 5c1, 5c2, 5c3 up to ncn. So 5c4, I add up here, so I'll just add over here, okay, plus 5c4, first term raised to 5 minus 4 is 1 and second term is raised to 4. Similarly, end up 5c5, first term raised to 0 and the second term raised to 5. So, and then afterwards you simplify. This is x raised to 5, this is x raised to 4x. So, eventually what will happen? 5c0, 5, 25, 25, 5, whatever the working. But what I want to observe is, if you see carefully, there is term 1, term 2, term 3, term 4, term 5 and term 6. So, in short, the number of terms after expansion is justified now. It is always n plus 1 term. So, it is raised to 5. So, total 6 terms will be there, 1, 2, 3, 4, 5, 6. You can evaluate this in the calculator, or you can also use the formula as NCR is n factorial upon n minus r factorial into r factorial. So, this is nothing but the combination formula. You can use your calculator, which you are allowed to use, FX82MS model. Now, once you finish with this, so this is the first form, first type of concept, I can say, in binomial theorem. The second concept, okay, now the second concept happens to be very, very important. Very, very important. This is the second concept. Because the third part, I will just mention it as third part. So, in the third part, if I want, now see what is important in all these pointers, that you have the first term, second term, third term, fourth term, fifth term and sixth term. When you expand, a plus b raised to 5. But suppose you raise to 15 and I ask you the 12th term. So, you are not going to open up everything, correct? No, you are not going to open up everything, that is 12 terms, mean 13 terms you are not going to write down, and then, sorry, if it is a plus b raised to say 5, if I want the fourth term. So, you are not going to open up everything, you can directly get the fourth term, that is Tn, the fourth term can be given as T of r plus 1. I want to take this out. The general term formula is given as NCR, the first term, of course for this expansion, first term is a raised to n minus r, difference of this which are applied here, and second term raised to r. So, this is a very, very important result, because this you are going to use in maximum questions, the general term. So, keep in mind we will be doing it. Now, for example, let us take the same example, and if I say find the fourth term, let us take an example. Let us take an example. Okay. If I say find T4, now T4 is nothing but T of 3 plus 1, because you have to write in this format, is nothing but NCR. Now, this is my R. So, N is nothing but I am taking this example, children. So, NCR is nothing, for this example you can say find T4, okay. For example, refer above. Refer above. So, let us see what happens if I use this formula. N is nothing but 5. So, 5CR, right, because any general term T4 you have to write in terms of R plus 1, okay, R plus 1. So, 5C3, first term, what is my first term? X raised to 5 minus 3 is 2, and second term 1 by x raised to 3. Now, look at this fourth term and look at this fourth term. Look at this fourth term. If you see, the fourth term here and the fourth term here remains to be same. So, what I am trying to do, I did not open up for finding the fourth term. I did not open up and then try to find out this is the fourth term, write it down. No. You can use the general term formula and find any term based on this, the expansion of a plus b raised to n. Now, in this I referred this above example. Got the point? We will do lots of examples in this as we go on. The next concept, very, very important concept I would like to share is, the next concept is called the middle term concept. Now this is an important one, pay attention now. Now when I say middle term, okay, now you all know when I open up there is n plus 1 term. Now in this case there are two cases. I want to put this point. Case 1, if it is n is odd, if n is odd, then the middle term, see if n is odd, opening will give you, after expansion will be even number of terms. So even number of the two middle terms will be there. Two middle terms will be there. How the formula is given to you? It is n is odd, so n plus 1 upon 2th term and n plus 1 upon 2 plus 1th term. Okay? So please understand this, because when n is odd, after expansion even number of terms will be there. So in even number of terms there is no middle term, right? So even number there is no middle term. So what I do, find the two, there will be two middle terms in case n is odd, directly given by n plus 1 upon 2th term and n plus 1 upon 2 plus 1th term. I hope that is very clear. Then case 2. Case 2 says if n is even. This is more easier. If n is even, remember how many terms you get, so it is the middle term. If n is even, how many terms you will have? Odd number of terms. In odd number of terms, say 5 terms are there, so first, second, third term will be the middle term. So when after expansion it is odd number of terms, finding the middle term is definitely much easier. So the formula is, middle term formula is given by n upon 2, I believe n is even, so n upon 2 plus 1th term. Okay, so basically understand this. When we are dealing with the example, you will come to know how we do about it. Okay, I will go about it. Then last but not the least, you have the middle term, you have the general term, you have the expansion. The last concept says that you can say rth term from the end. You know how the type of question comes up. For example, if I say for a plus b raised to 5 or a plus b raised to n, find the 6th term from the end. See, this formula is for from the beginning. The general term is for the beginning. From the beginning you can use this formula, not from the end. So whenever they ask you find the rth term from the end, that means you have to find, I change the wording there, that means we find n minus r plus 2th term from beginning. Okay, B-I-G-I, what from the beginning, I am sorry, B-I-N-G-I-N-G, okay, so just whatever the spelling comes up over there. So this is the pattern of questions which is there in binomial theorem. Are the basic questions and important questions, okay, it throws a lot of light on the concepts there. I hope you got this point clear, okay. So this is the way, first, second, third, fourth. Understand the concept. Now when the examples comes up, I will refer this formula and definitely come back to what I am trying to tell you all. Okay, so I hope you got this point clear, children. So this is what the basic concepts in binomial theorem. Now we will move ahead with the examples. What are the types of questions? Of course, I had touched those types in the explanation right now. So we will see something more about it as we go on. So we will start. Okay, great. So let us start now. The first question happens to be here. The first thing is that find the term independent of x. Okay, remember in most of the questions, you know, this general term will always help you. This general term formula will always help you. Keep that in mind. This general term, TR plus 1. Okay, now let me just get back to the question. They are telling us find the term independent of x. Find the term independent of x. Okay, find the term independent of x in the expansion of this. So definitely if I expand, there will be total how many terms? Can you tell me how many terms will be there after expanding this particular bracket? Come on, I want you to be a little bit quick with me today. 16, yes, 16 is absolutely right. 15 plus 1, 16 terms will be there. Okay. So one question, I will just explain you everything. So first question says, find the term independent of x. Now independent of x का मतलब क्या? X is raised to 0. मतलब a term will be there whereas x raised to 0. How will you find it? We don't know. So what we do in this, you first find r. Okay. Now you first try the r term. Tr plus 1 will be 15cr first term raised to what? Difference of this. I will tell you why I did this. Okay, 15 minus the second term raised to this term r. That's why I explained you. So independent of x means what? The x term should not be there, that the power of x should be 0. Now once you finish with this, remember I want this term to be independent of x. This term, this is a general term, it can be 5th term, 6th term, 10th term, but I specifically wanted term independent of x. There is no x. So what will be the value of r for which this x will vanish? So let us find this out. Now see, here there is root x, forget about these numbers, okay. So root x raised to 15 minus r upon x raised to 2r. You can say that way, right? But I want a term in such a way, I want the value of r for which this x raised to 0 will become. So how I get it? Which is equal to x raised to 0. Matlab the x term on left hand side raised to should be 0 because that becomes independent of x. Now I find r now. How? Now this is root. So root is x raised to 2, x raised to 1 by 2. So this I can write as x raised to 15 minus r upon 2 upon x raised to 2r is equal to x raised to 0. Because square root I can write as x raised to 1 upon 2. So 15 minus, this 2 goes out here, 1 upon 2, 15 minus r upon 2. So now same base I can say x raised to 15 minus r upon 2 minus 2r is equal to x raised to 0. Remember your objective, because I don't know that thing, find the term. To find the term you should know which term it is, 5th term, 10th term, 7th term, where it is independent of x. So that's why I am finding that term r. So coming to a point, if I equate this thing, 15 minus r upon 2 minus 2r is equal to 0. Same base I am equating the powers. So what happens guys, 2 to the 4r, so this will become 15 minus 5r, 15 minus 5r is equal to 0, 5r is equal to 15, r is equal to 3. Then only, so if r is 3 guys, the x coefficient in this will be 0. Done. That means I can get very easily, r is 3. Now look at this term. Look at this term. So the term is given as 15c3. 15c3. This will be root x upon root 3 into 15 minus 3 upon into root 3 upon 2x square raised to 3. So when you put r as 3 in this guys, the x raised to power will be 0. So that's what I wanted, the term associated with it. So what will be left out now? 15c3. This x there is no need to solve, because if you take it, it will be 0. If you want, you can check it out, because 15 minus 3 is 12. 12 this is raised to 2, raised to half, sorry, 12 upon 2 is 6. So x raised to 6, denominator 3 to the 6, so 6 minus 6 will become 0. You don't have to solve that and show, okay, it is understood. And because of this only you got r value as 3. I want the term. So 15c3, okay, now x term will be 0 and this is, understand, this 15c3 upon root 3 raised to 15 minus 3 is 12 into what will happen with this, root 3 upon what, root 3 raised to 3 and 2 also raised to 3. So root 3 cancels here, this 3 will get cancelled quickly, this root 3 times will get cancelled and this will get cancelled, and what will be left out here? 9. So in short, my term will be 15C3 x raised to 0. I can write x raised to 0 at the end. Here there is nothing, here there is, what is left out? This is nothing but 15C3. This is 1 upon root 3 raised to 9 and 2 raised to 3. Now if you see carefully, 15C3 will be 455. Can you calculate 15C3 what you are getting? Just check and tell me whether it is 455. Okay, they have mentioned, keep root 3 as it is, whatever stuff it is. So this is the term which I am trying to find out. Okay, they have rationalized this in the end and they get the final answer about this. So some root 3 will be left out here, right, and then we go about it. So this is the way you find independent of x. That means independent of x ka matlab hai x raised to 0. So what will be the value of r for which the x will be 0? That you first r, finding r, but the general term is very, very important. Okay, as and when the more examples will clear us more thing. Next. Okay, find the middle term. Oh great, now middle term, I told you what is the middle term formula. Find the middle term of the expansion p upon x plus x upon p raised to 9. Now by the way, as n is odd, how many terms after expansion? So after expansion there will be 10 terms. Now 10 terms में odd होता ही नहीं ना, 10 terms में odd होता है क्या? By the way, let me just take, I think there is some formula mess up there, 1 second. If n is odd, n plus 1 will be even. Sorry, I want to modify this formula there, I am sorry here, because it will be n upon 2 term and n upon 2 plus 1 term. So okay, so let us take this part. So as I said, if as n is even, as n is odd, then upon 2. So 10 upon 2th term and 10 upon 2 plus 1th term, because there will be 2 middle terms. So it will be 5th term and 6th term. So middle term. Now once I understand the position, it is very easy to use the general term formula and find the answer. Let us see. 5th term. Now let us talk about 5th term here. Okay. So my 5th term T5 will be TR plus 1 NCR, that is 4 plus 1. Na? 5 I can write as 4 plus 1, which is equal to 9C4, because R is 4, first term raised to difference 9 minus 4 5, and second term x upon p raised to this term. So what happens now? So t of 4 plus 1, that is the 5th term, is nothing but 9C4 p raised to 5 upon x raised to 5 into x raised to 4 upon p raised to 4. Now what happens? Just see. So it is the 5th term, it is 9C4, p will cancel, it will be p upon x. Can anybody tell me using the calculator what is 9C4? Quickly tell me what is the 5th term. Here I have given to you 126. Can you see that? Right. Now let us talk the next term. What is the next middle term? 6th term. What is the next middle term? 6th term. T6. So T6 you write R plus 1 format. Remember I had given you the formula, general term formula I had given you as R plus 1. So T6 I have to write like this, that is T of 5 plus 1. So R will become 5. Keep that in mind. Okay. So don't mess up the calculation skills here. So once you are done, let us take the 6th term. 6th term I can write it as t of 5 plus 1. 6 I can write. So what is my r value? 5. What's the formula? NCR. What is my n here? 9. 9C5. First term raised to difference of this. 9 minus 5, 4. Getting it? Then second term. What is second term? X upon P raised to this 5. Now I think it will be reverse. So 9C5. What is 9C5? I calculated 126. It is x is more here, so x upon p. Great. The second middle term also you got. So remember, after expansion there are even number of terms. So please don't mix up with the formulas. These formulas which I gave was correct because I denoted n as number of terms, whereas after expansion it is n plus 1 term. That's why I kept the formula as it is. Instead of redefining n, I kept it as it is, and based on that what I explained to you, I gave you this particular point of understanding. That is the middle term. Independent of x, x raised to 0. Keep that in mind. Okay, I hope you got. So middle term, I think T6 is the middle term. So my middle terms are 1 and the second middle term is here. Because after expansion the total number of term is even. Even में दो middle term होते हैं और अगर odd terms होते हैं तो उसमें only one middle term will be there. Okay. So next question. Oh, this same question now. I think same question. I want to remove this out because it is the same question as the first one. Actually, it is a root of x. Okay. So done. Question done. The first question was this one only. Same thing. Question done. Okay. Let us take the next one. Find the term free of x. It means the same thing. Oh, sorry. The question not find the term. 1 minute. Let me just put across this message here. If the term free of x, okay, if the term free of x in the expansion of root x minus 5 upon x square raised to 10 is 405, matlab the term which is free, the term is x, the term independent of x, free from x matlab x raised to 0 is this thing. So remember, anything you need to have the location r first to find. Okay, so let us find r first. So by the way, how I get r? The general term will be, you can say 10CR, okay, 10CR first term raised to what? Difference of this 10 minus r. Then second term, don't ignore the minus sign, it has to carry forward, raised to r. Now first thing, let us find r when x is raised to 0, because that's what they are asking. Free from x का मतलब क्या? X raised to 0. Free from x का मतलब क्या है? X raised to 0. So find r based on that. Then it becomes very easy to solve. So let us see this part. So here, now this is nothing but 10CR x raised to 10 minus r upon 2, right, minus k raised to r upon x raised to 2r, because this r belongs to both. Remember, to make x raised to 0, what will be the value of r that you have to find? So you consider the x term here. So x raised to, this will become 10 minus r upon 2. This 2r will go up, this will become minus 2r, and this will be x raised to 0. Because you have to find the value of r for which this will be equal, that is, this calculation will become 0. So what happens now? If I solve this out, this will become 10 minus 5r, right, 10 minus 5r, okay, is equal to 0 if I equate it. So r will be equal to 2. Now hold on, wait. Now don't jump the gun. Now they are telling us the term free from x. Now this is the, see, when I put r as 2, the term will be free of x. You want to check it out. What will be the term when I free of x now? Remember, this is r, this is the term which is free of x, that is when r is 2. So the term free of x will be 10C2 Okay, there is no need to write this, but still for your convenience I will write this. 10 minus 2 minus k upon x raised to 2 raised to 2. No, something is, yeah, correct. Okay, so I got, so if you solve this now, this is root 2, so upon 2 kar diya, there will be 4 and this will be 4, so x will go out. So what is the term? Term is 10c2 minus k raised to 2, okay, and x raised to 0. X raised to 0. What they telling? The term free from x in the expansion of this is 405. Matlab, this value, this is the term where there is no x. This value is 405. This is the term, right? Can anybody tell me what is the value of 10c2 quickly? What is the value of 10c2? 45, right. So k square 45 is equal to 405. So k square is equal to 405 upon 45. So let us do 5 9s are 45, 5 8s are 40, 5 1s are 9, 9s are. So k square is 9. So what is the k value eventually? Plus or minus 3. K value is plus or minus 3. So understand, it's very easy trying to put this thing into your mind. The term free of x is given to you. What is the term free of x? Matlab x will not be there. So if x is not there, this term will be the free of term, which is x. But before that, always find r in every question. In every question you have to find r by using the general term. This is the general term value, na, tr plus 1. That is NCR. What is my n? 10. So NCR first term into 10 minus r raised to, and into second term raised to r. So from here x raised to 0 has to be there. So for what value of r the x will be 0, that I calculated here. R is 2, and then I worked out. Okay, I hope you are, children, are you getting the point which I am explaining to you, or I can make it more better for you all? Okay, should I make it more better? Okay, let us see the next question. I will make it more better for you. Find the 13 term. This is a very simple question. They are asking T13. What is T13? 12 plus 1, R plus 1. I told you TR plus 1 will be NCR. So 13 term they are asking means T of 12 plus 1 is nothing but NCR 18CR. R is 12. Okay, 1 less. First term raised to 18 minus 12, that is 6. And second term, don't never ignore the negative sign. 3 root x raised to 12. So can somebody tell me now what is 18C12 quickly? Can you calculate and tell me what is 18C12?
18,562.
I am not calculating it, you do it. 18C12 will be there. Now this 9 raised to 6 will be there, x raised to 6 will be there, minus raised to even one number will be positive only. So 1 raised to 12 into 1 upon 3 raised to 12, 3 raised to 12, this 12 belongs to both. So 3 raised to 12 into, now hold on, into, now root x raised to 12 is nothing but x raised to 6, correct or not? So what happens now? I quickly cancel it out. So what happens now? I finish out with this T13, 18C12, 9 raised to 6 upon 3 raised to 12. Can you calculate this on your own? I think you should get 18564. Please try it out. I just give this 1 minute for you. So this is the way, this is the pattern of looking. I hope you got this. I think, are you getting the same answer? Zoya? Others? Diya? Please calculate this.
Same answer.
Thank you. So I think which is equal to 18564. I am taking it down from there, so don't bother. But I know after confirming from y'all, I am telling you this is 18564. Thank you very much. So very easy. So r plus 1, r plus 1. Now this is a nice question. Same thing like independent of x. Independent of x matlab kya? X raised to 0. So this is x raised to, they are asking find the coefficient of x raised to 15. Easy, very easy. First thing, as I said, any question we always find r. So I think tr plus 1 will be NCR. I don't know what is r. I will talk about this coefficient of x raised to 15 later on. First you find r for which this will become 15. Okay, it become easier. So NCR, first term raised to 10 minus r, second term raised to r. Now what should be the value of r so that we get x raised to 15? So look at the x term first. So x raised to 10 minus r, and forget about this minus sign, x raised to 2r. Now to get x is should be equal to x raised to 15. So find r, x raised to 10 minus this addition of this x term should be x raised to 15. So I think I am very clear now. This will become, if the bases are same, this will become x raised to 10 minus r plus 2r is equal to x raised to 15. So this will become x raised to 10 plus r is equal to x raised to 15. So I think r is 5. Once you get this, it's very easy. So I want, when r is 5, the x will be 15. You can put, see, 10 minus 5 is 5 and 2 5s are 10. So 10 plus 5 will become 15. That's the beauty. So now I want the coefficient of x raised to 15. So this is the thing, 10c5 x raised to, this will be 10 minus 5, this will be minus of, this will be nothing but x raised to, this into, by the way, hello, this is into x raised to 10. Getting it? So minus raised to odd number, even number will be positive. So I think if you see there is no other number, only 10c5 minus raised to, yes, sorry, minus raised to odd number will be minus only. So this minus, please understand this. Understand this. This is, see, it's not minus x raised to 10. I'll just show you this. See, it was minus x square raised to r, correct? So this is minus x raised to 2 raised to 5. I got this. Now when I apply to both, now minus raised to odd number will be minus, and this is x raised to 10. So eventually it will be minus x raised to 10. So minus, I want to write it out here instead of inside. Got the point? Okay, so it is. Who will tell me what is 10c5 you are getting? Are you getting 252? Thank you. So that's the catch here. So simple it is minus 252. Do you get that point clear? Okay. Just have a look at that question, how we are done. B is the real number and middle term value is given to you. What is the middle term given to you? 1120, find P. By the way, you tell me, after expansion how many terms is there? It will be 8 terms or 9 terms? Bolo. As n is odd, even, sorry, in this case it is even. N is even. What is the middle term? Can you tell me what is the middle term? It will be n upon 2 plus 1th term, correct or not? Hello? Will it be n upon 2 plus 1 term? Yes. So this is nothing but 8 upon 2 plus 1th term, which is nothing but what? 8 upon 2, 4 plus 1, 5th term. 5th term. I hope I don't know, something striking me somewhere. If n is even, oh God, I think here once again, I think something is fishy there. 1 minute, no, it is n upon 2 plus 1. Just go refer my lecture there, because I think if n is even, n upon 2 plus 1 term, so here it should be n upon 2 plus 1 term. No, it's right. Okay. Okay. So I think I want to change a little bit. So n upon 2 plus 1 term. So I think it is 4th plus 1, 5th term. So 5th term. So I want to find 5th term. So 5th term T5. So I can say 4 plus 1. So what is my R? NCR 8C4. First term raised to 8 minus 4, 4. Second term raised to 4. Now let me just, if P is a real number, the middle term in the expansion is 1120. This middle term value is 1120. They are asking find the value of P. My job is over. Can somebody tell me what is 8C4? What is 8C4? 8 factorial upon 8 minus 4 factorial into 4 factorial. So 8 into 7 into 6 into 5 upon 4 into 3 into 2 into 1. So 3 2s are 6, 4 2s are 8, 2 gets cancelled. 70. Are you getting 70? Right. So 70 into, this is 2 raised to 4 and 2 raised to 4 get cancelled, into P raised to 4 is equal to 1120. So P raised to 4 is nothing but 1120 upon 70, cancel. 7 1s are 7, 7 6s are 42. So P is nothing but 2. Something very clear, it's not difficult at all. Okay, don't no confusion there. Stick to whatever the notes I had given you about the middle term. Just keep in mind. Okay, because as n is even and after expansion it becomes odd. So best is if depend on n is even, n upon 2 plus 1 term is the middle term. If n is odd, then n plus 1 upon 2 and n plus 1 upon 2 plus 1 term. Same formula which I mentioned. So just in the end, when I share the note, modify the formula, because I just modified something to my convenience. I don't want to remember n is even a, then odd number, even number. I don't want to think about that. Just simple formula we follow. I hope you got this point clear. Okay, got it? Right. One last question. Yeah, this is a nice question there, because find A if the coefficients of x square and x cube are in the expansion of 3 plus ax raised to 9 are equal. Find the answer. Now coefficient of x square. Now wait, coefficient of x square is equal to coefficient of x cube. Now before that, I really want you to introspect. I told you without r there is no working at all. So first find r, where it is x square. For x square, what will be r? What will be r? I am writing this so that you understand it. So tr plus 1 is ncr, n is 9, cr, first term. What is first term? First term raised to 9 minus r, and second term is ax raised to r. Now I want the x square, that is x raised to 2. So x raised to 2. So there is only one x is raised, here only one term of x is there. So x raised to r is x raised to 2. So what is my r? So r value is 2. So what is the term I am getting? This is the term, coefficient of r raised to coefficient of x raised to 2. So this will be 9c2 3 raised to 9 minus 2 a raised to 2, and I think this is the coefficient of This is the coefficient of this, because if I say x, x raised to 2 will be there, na? So I don't write this, the coefficient of x square. Similarly, coefficient of x cube, now in x cube ke liye same thing I have to find r, so this will be NCR first term raised to n minus r, second term raised to r. So what will be the value of r, so that it will be x raised to 3, x raised to 3. So x raised to 3 ke liye r, if you want to calculate this, you can just have a look. So here if you see this, only x is there, x raised to r is equal to x raised to 3, r is equal to 3. So when I put r as 3, I get this term as x raised to 3. So this will be t 3 plus 1 is equal to 9c3, 3 raised to 9 minus 3 is 6, and by the way ax, I really don't know, this will be a raised to 3. Okay, I'm telling this is the coefficient of, okay, so I don't want to write this term matlab x bhi aayega usme. So coefficient of x cube is this. Now if you see, this term is equal to this term. Now let us see how I calculate. So I am writing this off quickly now, just a second. Okay, I get here 9c2 3 raised to 7 a raised to 2 is equal to 9c3 3 raised to 6 a raised to 3. So immediately I don't have to think much. This cancels, this will cancel, this cancels, this will cancel. So what remains here? It will be, bolo, it will be 9c2 into 3 is equal to 9c3 into a. They are asking find the value of a. Can you tell me what is 9c2 you are getting? Fast? Huh?
36.
36 or 46? So 36. What is 9c3? 84a. So I am solving it over here now. So I think it is 36 into 3 upon 84 is equal to a. So let us see if I cancel what happens. 6 6s are 36, 6 1s are 6, 4s are 24, 2 3s are 6, 2 7s are 14. So my a value eventually 3 3s are 9 upon 7. This is what exactly I am getting, 9 upon 7. So understand, for every sum you need to find r. Without r you will always have. Keep that in mind. Okay. So that's the funda, that's the point. The general term formula will always come to your rescue in whatever best way it is possible. So I hope you got this point. There are some questions there. It is very similar lines, these questions are there, very much simpler questions actually, not much to deal with it. Okay. So these two questions now, I think we are short of time, so those two questions I will leave it for you all to complete it up. But I hope in general you understood what we are trying to work out, right? These are the different questions which we saw, right, and main formula were always there. So I hope it satisfied you to some extent. Try to work out the sums based on these lines, will be terrifically useful. We will continue with this binomial theorem, at least 4 or 5 sums more I want to do in the next lecture beginning, and then we will go to index number after that. Okay. So thank you very much for being with me, children. God bless you all. Stay safe and stay healthy.